A hand-drawn cliff, a rope bridge, and a glowing beacon. Could Kimi K3 turn that idea into a real Blender scene? This video shows the useful version of that claim, a reproducible prompt contract, a lightweight Blender Python build, a local render, and an honest review of what still needs human judgment. Kimi K3 launch coverage is moving fast, but most videos repeat the same model size and benchmark story. The stronger creator angle is visual, concept to editable 3D. Search results already show interest in sketch-to-game and 3D website demos. Blender adds something those clips often miss: geometry you can inspect, edit, save, and render again. According to Moonshot AI, Kimi K3 is a 2.8 trillion parameter model with native vision and a 1 million token context window. The official release specifically highlights long horizon coding and visual reasoning for game development and digital creation. As of July 20th, 2026, the model is available through Kimi products and its API, while full weights are planned for July 27th. The important boundary is simple. Kimi K3 is not a Blender add-on. It can plan, reason over references, and write a Blender Python script. Blender remains the execution environment and the source of truth. The reliable loop is prompt, review, run, render, inspect, and revise. Skipping any of those steps turns a useful workflow into a magic trick. A vague request like make a cool scene is almost impossible to evaluate. The prompt should name the software version, the scene elements, the palette, the allowed dependencies, and the required outputs. For this demo, the contract is Blender 4.2, built-in primitives only, a low-poly cliff diorama, a rope bridge, a cyan beacon, Eevee Next lighting, a saved blend file, a hero still, and a short orbit animation. The best generated Blender script is not clever. It is boring and deterministic. First it clears the default scene. Then it creates named materials and lightweight primitives. It builds the cliffs, planks, ropes, beacon, lights, and camera in a predictable order. Finally, it sets the renderer, output resolution, file paths, and animation frames explicitly. That structure makes the code easy to audit before Blender executes it. The scene is generated locally with Blender in background mode. That means there are no manual clicks hidden between the prompt and the result. The command launches Blender, runs the Python file, saves the blend project, renders 6 stills, and exports a 6-second camera orbit. Because the build uses no add-ons or external models, anyone with Blender 4.2 can reproduce it. Here is the actual local render. The scene contains editable bridge planks, rope curves, low-poly cliff meshes, a beacon built from cylinders and emissive rings, and 2-color lighting. It is not a flat concept image. The blend file contains the objects, materials, camera keys, and render settings, so the shot can be changed instead of merely admired. The biggest K3 opportunity is not the first code draft. It is the next iteration. Render a frame, let the model inspect the image, identify one visible issue, edit the script, and render again. In this build, the first cyan rim was badly overexposed. Reducing only that material's emission fixed the base without changing the bridge or beacon. That is what vision in the loop should look like: one diagnosis, one controlled change, one new piece of evidence. This workflow is fast, but it is not one-click production art. A human still chooses the visual target, checks topology, decides whether the geometry is game-ready, and judges camera, lighting, scale, and composition. Generated scripts can also include unsafe file operations or expensive settings, so code review is mandatory. K3 can compress the distance from idea to editable draft. It does not remove the need for Blender knowledge. The reusable recipe has 5 steps. First, describe a visible target, not a mood. Second, constrain dependencies, version, polygon density, renderer, and outputs. Third, review the generated Python before execution. Fourth, run Blender locally and capture a render as proof. Fifth, iterate from that frame with one change at a time. Save the prompt, script, blend file, and final render together so the workflow remains teachable and repeatable. So, can Kimi K3 help build a Blender scene from a sketch? Yes, if the claim means planning, code generation, visual iteration, and a real local Blender project. The winning YouTube story is not that an AI made perfect 3D art instantly. It is that a simple sketch became inspectable geometry through a workflow viewers can repeat. The full script and blend file are included with this video package.